Okay, so let's look up the electronegativities of hydrogen and oxygen. And again, I don't have them memorized, so I need help on these. So we're going to say hydrogen is going to be 2.2, and oxygen is going to be 3.4. See oxygen there, 3.4? So if I subtract the two of these, 3.4 minus 2.2, I'm going to get an electronegativity difference of 1.2, which is less than 1.7, confirming that it is covalent. Okay? Covalent substances are going to be made from two nonmetals. Nonmetal, nonmetal. Ionic, metal, and nonmetal. So far, so good? Okay, just making sure, because the first thing I'm going to ask you, and I know what's going to happen, is I'm going to say, is it an ionic compound or a covalent compound? That's a very good question. Okay, if it's at 1.7, you're going to look at what types of elements are making it up, and then you're going to make a judgment. Now, for a Regents level class, they're not going to give you exactly 1.7. They're going to give you sodium chloride. They're going to give you potassium fluoride. They're going to give you a really ionic substance, or they're going to give you one that you know is covalent, like water is covalent, carbon dioxide is covalent, ammonia is covalent, all of those things. Okay? All right, so now we know that it is covalently bonded, which means we are going to be sharing electrons, not transferring them. Okay? So this hydrogen, just look, don't write. This hydrogen needs 2 electrons. It only has 1. It comes over and it says, oh, look, I can use one of yours, oxygen, and one of mine, and we can share these 2 electrons. That we will call a covalent bond. It is sharing the valence electrons to complete. So this hydrogen now has use of 2 electrons, and this oxygen now has a total of 7. Well, I've got another hydrogen over here. I'm going to move this electron to the top just so that it fits better. And I'm going to come over and I'm going to put that there. Isn't that nice and neat? I'm going to make these X's only so you can see that they're different than the oxygens. So this right here, this hydrogen has 2 electrons. It's got a full valence shell. This hydrogen has a full valence shell, and oxygen now has a full valence shell. This right here is a covalent bond. It is between 2 nonmetals that have an electronegativity difference of less than 1.7, and they are sharing the electrons between them. This is not a salt. This is a molecule now. It is a discrete particle. Can I make any bonds out here on this hydrogen? Can anything else come up there and bond right there? Why not? There's no more valence electrons to work with. Good. These 2 electrons over here and these 2 electrons over here are called non-bonding pairs. Non-bonding pairs. A covalent bond is made from 2 electrons. Usually 1 from one and 1 from the other. Not always, but usually 1 comes from one and 1 comes from the other. Okay? Now, there's covalent bonds. There's lots of different types of covalent bonds, but this is the crux of it. Okay? If I wanted to make a bond between, let's say, hydrogen and hydrogen, this is the simplest covalent bond there is. This hydrogen comes, that hydrogen's there, there's your covalent bond right there. One electron came from this hydrogen, one electron came from this hydrogen, and both of them get use of those 2 electrons. Okay? Is this a molecule? Yes, it's a molecule. It's a molecule because it has a covalent bond in it. Okay. What about chlorine and chlorine? 1, 2, 3, 4, 5, 6, 7. And let's draw another chlorine. 1, 2, 3, 4, 5, 6, 7. Is that going to form a covalent bond? Yes, it is. I drew the dots so that they would fit together when I moved them. Whoop. And there you go. Now this chlorine has use of 8, and this chlorine has use of 8. And these 2 electrons right here are forming the covalent bond. Properties of covalent bonds: low melting point, low boiling point. You just wrote all that stuff down. Okay? They're molecules. They're usually soft and smushy. Okay, think waxes. Those are molecules. The electrons are being shared. I just showed you a very simple sharing of electrons. They're low melting and low boiling points. Candle wax. They never conduct electricity. Ever. What is electrical conductivity? What do we need in order for there to be electrical conductivity? Well, metals do conduct electricity, but what do we need in order for there to be electricity? Movement of electrons or ions. Are these electrons moving? Nope, they're locked in place right in between those 2. Okay? They are locked in place. So covalent, there's no ions and there's no moving electrons. So there's no conducting electricity. Their electronegativity difference is going to be less than 1.7. Okay? And the less electronegativity difference you get, the more covalent you're going to be. So all these guys down here are going to be covalent. And as you get less and less electronegativity difference, you're going to get more and more covalent. As you get a higher electronegativity difference, you're going to get more and more ionic. Go ahead. Yep. That's coming. Okay? But right now, all I want you to know is the difference between an ionic and a covalent bond. Okay? And that's what we're going to practice now. We're going to say, do we have ionic? Do we have covalent? I don't think there's any that are a mixture in here. Yeah? Oh, yeah, there is one. If I can find it, I would be more than happy to. You know what? Let's put it. It is on this worksheet, so let's talk about it, okay? And then I'll give you this to work on. And the next couple of days, we're going to be drawing ionic compounds. We're going to be drawing covalent compounds, and we're going to be practicing naming them. We're going to write the formulas for them. So we got a lot of work to do. Just waiting for Dylan to be done. Okay. That calcium is going to lose electrons. This sulfate, even though it's a polyatomic ion, is going to be gaining those electrons. That's how it got this -2 charge right here. Okay. So this electron is going to come here. This electron is going to go there. Now all of those guys are all taken care of. But this calcium is a +2 charge, and this sulfate is a -2 charge. I hope I didn't just confuse you, because there's parts that you don't know yet, so I'm kind of just trying to skirt around it. Okay? The bond between the calcium which is the metal, and the entire SO4 is ionic. The bond within the SO4 is covalent. So, bottom line, if you have something we call a ternary compound, ternary, which means it's going to have 3 or more elements, and one of those in that ternary compound, there is a polyatomic ion, you're going to have both ionic and covalent bonds. So if you write something like this, CaSO4, that is a ternary compound. It's ternary because you've got 3 elements, Ca, S, and O. Within that, do you have a polyatomic ion? Yes, the SO4. If you have a polyatomic ion and it's ternary, you're going to have both ionic and covalent bonds. Within the polyatomic ion are the covalent bonds, and with the polyatomic ion and whatever else it is going to be an ionic bond. Here's a tricky one. NH4Cl. Does that have both ionic and covalent? Yes, it's ternary. And you have a polyatomic ion right here. This is ammonium, NH4. So this has both ionic and covalent, even though they're all nonmetals. Because this whole thing right here is acting like the metal. That's the cation. And this right here is the nonmetal. Okay. So that kind of answers your question. Can you have both? Yes, you can have both. How do you know if you have both? It has to have at least 3 elements in it, and it should have a polyatomic ion in it. So C6H12O6, glucose, from back in your living environment days. Is that have both? No, because this does not have a even though it's ternary compound, it doesn't have a polyatomic ion in it. Okay? NaC2H3O2. Yes, it has both. You've got your acetate ion. We played Yahtzee, right, with our polyatomic ions. That's the acetate ion. There's the ionic bond is between the Na and the acetate, and inside the acetate are covalent bonds. Okay? And again, there's stuff you don't know, so I'm kind of trying to explain it without giving you so much that your head is spinning. Okay? So let's just recap. In an ionic compound, this is just a recap now. You have a transfer of electrons. And it goes from the metal to the nonmetal. You're going to have an electronegativity difference that is going to be greater than 1.7. You're going to have high melting points and high boiling points. They only conduct in water or liquid form. Covalent share electrons. 2 nonmetals. Their electronegativity difference is going to be less than 1.7. They have low melting points, low boiling points, and they never conduct electricity. Can't squeeze that I in there. Okay. When you draw an ionic compound, you're going to use the brackets. Sodium with 1 valence electron, chlorine with 7. You're going to show the electron moving. And then you're going to have sodium in brackets with the +1 and chlorine in brackets with the -1. That's how you draw an ionic compound. If you're drawing a covalent compound, you don't do all this fancy bracket stuff. I'll just draw water because it's a nice easy one. You just move the electrons in. There's a series of steps for these covalent ones when you get more complicated. Any questions on the difference between ionic and covalent? And then last we just talked about if they have both ionic and covalent, how do you know? You're going to have a ternary compound. It's going to have a polyatomic ion in it. A ternary compound with a polyatomic ion. All right, let's practice some of these because I'm giving you a lot.